Hello guys, in this video we are going to solve irrational integrals. The idea is that we are going to focus on a specific type of irrational integrals, an integral involving square roots, for example, and we will use a change of variables to transform this irrational integral, this integral with square roots or fourth, nth roots, into a trigonometric function. In this case, it is a very specific case. The requirements, okay, some notions of integration and calculus, derivatives, integrals, and we need to know how to simplify mathematical expressions. So let's go directly to the topic. Okay, so we have these two types of integrals. Look at the shape. It's a square root of a squared minus x squared, differential of x. A could be any number. It's going to be a, at the end, it's going to be positive. Take it positive, okay? This integral could be of this shape or just 1 over the same square root of a squared minus x squared. The idea of these integrals is to apply a change that kills the square root or eliminates the square root, or in a better way, it simplifies the square root, okay? One change that can do this is a times sine of t. I guess, in my experience, that some of you are thinking, I know how to do that perfectly. Why not to call a squared minus x squared? I mean, everything inside the square root, let's call this t squared. Okay, if you think it's good, try. You will discover that if you use this change, just call everything under the square root, you call it t squared. The idea is that when you calculate the differential, another square root appears. So it's like, okay, it's a cycle in which you are never going to get rid of the integrals, okay? So that is why this change, a sine of t, comes to help. It's a very good change. And we will use this formula later. This change is related with this property of sine and cosine, okay? So we are going to change this x by something or multiply by sine multiplied by something, and when we square this, we will apply this formula later, okay? Just keep in mind that this is the change. Let's see an example, really fast example. We want to calculate a square root of 25 minus x squared. Okay, so in this case, the change, since a in this case is 5, be careful, it's the square root of the number that appeared here. So the change is 5 times sine of t. If we calculate the differential, we calculate the differential, the derivative of x, differential of x, and the derivative of 5 times sine of t, it's obviously 5 times cosine of t, differential of t. Okay? Now, what to do next? We are going to change x by 5 times sine of t, and the differential of x is going to be changed by 5 times cosine of t. This is exactly what I just did here. As you can see, x has been changed by 5 times sine of t, and the differential of x has been changed by 5 times cosine of t. Now, the rest of the integral is just to simplify this expression. How do we do that? Okay, let's see. As you can see, I'm squaring here 5 times sine of t. There is a mathematical property that states that if I have a product power to a number, it's the first number power to the exponent and the second power to the exponent. So 5 times sine squared is 25 sine squared. Okay, so I have 25 here and 25 here. I can factor this number. So what I'm writing here is the simplification of this expression. I just factor 25 and what remains here? 1. And what remains here? Sine squared. Okay, I just moving 25 outside of this expression. Okay, and 5 times cosine of t is left here untouched. Okay, I'm not doing anything else. By the way, this 5 is a constant, can be written outside of the integral, and is what we are going to do next. Okay, so, and also, be careful, I just moved the 5 outside, and I just moved this 25 outside of the square root. The square root of 25 is 5. I can do that. The square root of a product is the product of the square roots. Okay? So this square root of this product is the square root of 25 times the square root of 1 minus sine squared. okay? So 25 goes outside as a 5 that multiplies this other 5 and becomes 25 outside. And also, what we have simplified here already is 1 minus sine squared. Oh, if you remember, I just show you a formula here. If I move sine squared, sine squared to the other part of this equation, becomes 1 minus sine squared. But 1 minus sine squared is cosine squared. So that is the reason you see here cosine squared, because 1 minus sine squared is cosine squared. And now the next stage is to simplify the square root with the square here. So this part becomes cosine of t, and we had already cosine of t outside. Cosine of t times cosine of t, cosine square of t, okay? And remember that it's not so difficult. You need to get used to these steps because it appears many times, and although it seems easy, or maybe you could think you can understand this easily, the next time can become difficult. So if I were you, I would practice these exercises again and again until you really manage perfectly solving these exercises. Okay, why I stop in integral of cosine squared? The integral of cosine squared is a very known integral, and my advice is for you to remember the solution. Okay, you can solve it by many ways. One is integration by parts. It's done, but it takes longer. You can also apply trigonometric formulas in order to solve cosine squared, because cosine squared of t is 1/2 times 1 plus cosine of 2t. And you integrate this expression and you got it. But my advice is, it's going to appear so many times that please remember the integral of cosine squared. And what is the integral of cosine squared? It's t plus sine of t cosine of t divided by 2. Okay, so we just apply the solution. If not, it's going to take longer, much longer. So my advice is, it's a very common integral. Please remember the integral. Okay, so this is the solution. I forgot plus c. Okay, be careful. My fault here. And then we need to go back and undo the first change. The original change was x equals 5 times sine t. So if I solve for t, it becomes the arcsine of x over 5. 5 goes down here, dividing. The inverse function of sine is arcsine. Be careful. I don't want anyone to be saying that the inverse is 1 over sine. Okay, that's not right. The inverse function of sine is arcsine. Okay, so I only need to replace t by the arcsine of x over 5. I just replace t by this expression, I just replace t by this expression, and the t here by this expression. There's one easy simplification here, is the sine of the arcsine. Both are inverse functions of each other, then disappear, they cancel, and the only thing left is x over 5. So this is the solution. I need to add, I just forgot here one plus t. This equal should be plus c. Okay, next one, easier in this case. No, it's not the easiest. But in this case, it's the same process, the same change, everything the same. But this is easier. Let me show you why. The square root of 9 is a. So I apply the change x equals 3 times sine of t. The derivative, 3 times cosine of t. Piece of cake. Then I'm going to replace everything on the integral. X is going to be 3 times sine of t, dx is going to be 3 times cosine of t. Perfect. As before, the only difference now is that the function is on the denominator. Then if you replace, we got, when I change x by 3 times sine of t, it becomes 9 times sine squared. And on dx is just 3 cosine of t. Okay, 3 goes out, as you can see. Inside the square root, I factor 9. 9 can be taken out from the square root, becoming 3. And this 3 and this 3 are going to disappear, as you can see here. Okay, becomes, here I just did it more slowly, or slowlier in this case. Okay, so square root of 9 is 3, 3 disappears with this 3, and 1 minus sine squared, as before, is cosine squared. So I'm going to change 1 minus sine squared here by cosine. okay? Square, by the way, okay? So we got this. A square and the square root cancel each other, so I got 1 over cosine of t times cosine of t. Cosine and cosine simplify, and the only thing left is 1, and the integral of 1 is t plus the constant. Then let's undo this change. X was 3 times sine of t, so t is the arcsine of x over 3. So I just changed t by arcsine of x over 3, and we got it, okay? In this case, this simplification at the end helps a lot, so it's a very easy integral. Okay, guys, so what have we seen? We just reviewed a special type of irrational integrals that becomes a trigonometric integrals at the end, or in the second case, just disappear, and it becomes something trivial. I hope you find this useful for you, and remember that these are very important irrational integrals. Thank you for your attention, guys.